Hello, my name is Sunny Yeager. I'm the chief from the Department of Simulation at Fort Belvoir Community Hospital, and I've been doing simulation-based education, or should I say, involved with it since 2008. Just like most of everybody, I just kind of dove into that realm and just learned from on-the-job experiences. But I also have formal training. I received a medical modeling and simulation certification from the Naval Postgraduate School, earned my certification, a CHESI certification from the Society of Simulation in Healthcare, and recently graduated from the Uniformed Services University School of Medicine's Health Professions Education Program, where I earned my master's. So in this literature, I worked with Abigail Konopasky as well as Alexis Batista, who are both faculty at USU, to publish this literature in discussing the concept of reliability in healthcare simulation setting, a definitional review. So I'm not going to sit here and, read out the definitions because that would be kind of boring. But what I actually like to discuss is my experience in the process of, developing, underpinning this literature with learning theories and a simulation framework. And so the combination of those two actually illuminated a pathway to collect the data that I needed to better understand the concept between reliability in HPE as well as in healthcare simulation. And I think it's important to underpin scholarship with theoretical frameworks because for simulation as a learning and teaching modality, it builds meaningful learning experience for students. And a conceptual framework for simulation as a learning and a teaching modality would offer healthcare educators the best model to design and deliver, assess and evaluate simulation-based learning activities in healthcare education. So with all that being said, let's go ahead and get started. My views don't reflect the official policies or positions from the uniformed services. So again, the goal is quickly, like I discussed earlier, is linking a learning theory to help you better understand of linking a learning theory and a simulation framework and how it illuminates a pathway for research or any phenomenon that you're trying to study. In my case, it's the concept, or should I say in our case, it's the concept of reliability. So my objectives are, because I have a lot of pictures here, is to illustrate the concept of reliability between HPE and simulation in a simulation setting, apply theory towards the assumption that reliability in HPE translates over to a healthcare simulation setting, and I'm going to showcase how a simulation framework guided the exploration to answer the research questions, which has to do with how reliability has been defined and described in literature, and what other relevant terms are tied to the concept of reliability in a simulation setting. And then I'm going to go ahead and showcase some research results to include a simulation theoretical framework that showcase how to operationalize a reliable simulation setting, although it hasn't been tested yet. But if that is something that you're interested in doing, I would love to know. So social factors and simulation setting interactions influence how participants achieve their goal-oriented activities, a concept not normally considered in the assessment realm of health professions education. Health professions education is a growing niche to prepare academic leaders for future challenges in developing the following skills. To calibrate your thought processes for this presentation, we are going to be focusing on assessments, specifically the concept of reliability in HPE and of a healthcare simulation setting. For me, reliability was a difficult concept to grasp, so I'm assuming it may be for others. So I will try my best to provide some illustrations through my presentations. First, reliability in essence determines if a tool is able to uniformly be repeated to provide fair and trustworthy evidence. Now, when I'm referring to a tool used in healthcare simulation, I am specifically talking about the educator as an observer. They are considered a tool because they are the ones who are subjectively interpreting participant behaviors in a simulation setting. This is important to understand because for learners, not only do they rely on their KSAs to elicit the ideal behavior educators seek to observe, they also rely on an educator's observation to determine if a learner is competent or not to proceed to the next level of their education endeavor. To paint you a picture of reliability in HPE, pretend these waveforms represent an educator's subjective interpretation of an individual learner's behavior who just went through the same simulation setting. These waveforms spinning represent a participant's behavior. If all of them were superimposed, we can see that there isn't any variation among them. But let's say there were variations in the frequency or amplitude of each waveform. Then the idea is that the aggregation of this collection of evidence should diminish the amount of variation across assessments. In other words, quantifying this evidence should reach as close of a score of 1.0, making the determining factor if a participant surpasses the competency threshold. A value of 1.0 looks like my initial example when it was identified that each waveform was uniformly repeated, thus providing evidence that the observer is doing their job in providing fair and trustworthy evidence, also known as the tool is deemed reliable. So now that we know reliability in HPE only accounts for two constructs, or layers that influence the achievement of assessment reliability, which are an educator's subjective interpretation of a participant's behavior, or errors from an individual's own performance. This idea illuminates that implicit assumption that the concept in reliability in HPE translates over to the realm of healthcare simulation setting. I would like to explain to you theoretically why this is thought to be true, so please hear me out. The purpose of a learning theory is to explain patterns, predictions, and conditions to reveal some phenomenon like specific behaviors. This is why we design simulation to elicit behaviors we as educators seek to observe from participants. This is also the reason why we incorporate Bloom's taxonomy when we develop learning objectives and Kirkpatrick model to analyze evaluation of outcomes to determine a participant's aptitude. Theories also posit that under certain conditions, behaviors will be repeated. Take, for example, a simulation design for a performance test like an OSCE. Simulation designers and educators may predict that the tailored design creates the conditions for participant behaviors to be repeated among individuals across a rotation schedule. This is why it may be assumed that a simulation could be implemented in the exact same way it was designed, and that the setting will expose participants to the same conditions, thus believing that participants will be provided fair and trustworthy experiences in a simulation setting in order for them to perform their activity without less interference. Or should I say, with less interference. One theory that assessments yield to is constructivism, which is an amalgam of other types of learning theories, with the notion that knowledge involves the co-constructions of experience gained and its capacity to manage the complexity proposed by patients. I use this theory as a strategic approach to draw from various perspectives of other authors throughout the literature review process. As a phenomenon, it also provides opportunities for assessors to observe participants' in actions as they respond to complex challenges. According to Dykman, healthcare simulation can be viewed as a social practice where participants interact in a goal-oriented fashion with the simulation setting characteristics, in a goal-oriented fashion with the simulation setting characteristics, mediating factors, and the environment. When designing for simulation, designers consider characteristics, mediating artifacts, and the environment. Characteristics are often discussed through such constructs, shown here. Mediating factors influence participant actions, like these ones that are shown here. And lastly, designers consider the environment, for example, in situ simulation or mobile simulations for the environment that move from one place to the other, like the ED to the cath lab to test out a STEMI protocol. Implementation operationalizes a dynamic setting. As a conglomerate, the concept of reliability, application of constructivism theory, development of a simulation framework equals a conceptual theoretical framework. This framework guided exploration of the literature to answer the study's research questions. What other relevant terms are tied to the concept of reliability in simulation, and how has reliability in healthcare simulation been described defined and described in the literature. The results identified 6 terms tied to the concept of healthcare simulation. It described the concepts of identified terms, illuminated 9 specific constructs, revealed a simulation setting framework, illuminated 6 SP training process, and identified 2 terms tied to the concept of operationalizing SP standardization. Using in vivo qualitative analysis software, I screened 234 articles performing a word frequency search and coded these terms revolving around the context of a simulation setting framework. Remember the Venn diagram. This process allowed me to exclude 72 articles even though they described a simulation because they correlated to evaluating the construct of education achievement, which is what we don't want since the construct of education achievement is related to reliability in HPE. What we want are articles related to the construct of a social practice in healthcare simulation setting, thus winnowing the systematic review to 50 articles that do fit our study's frame. Now I realize that I'm recording this, so please feel free, at any moment, in the future to go ahead and rewind this and pause it. My goal is to put it on YouTube. What we found was there was little discussion on reliability in the realm of healthcare simulation setting as a social practice. This slide answers one of my research questions. Based on what authors believe to introduce setting errors, which we'll get into the next slide, these terms suggest the process used of how authors tailor training for SPs in order to mitigate errors introduced by their behaviors. These errors are presumed to not provide the fair and trustworthy conditions that learners should get to achieve their activity-driven goals. These terms identify how authors believe simulation settings can be achieved, processes used to train SPs to mitigate or diminish the introduction of errors, and accuracy achievement, or what we understand in HPE as validity. The concept of reliability varies due to performance nuances. Bottom line, the overarching theme here is that when combined, these are the design attributes and SP performance tasks researchers recognize that introduce errors into a setting, consequently impacting how a participant responds to stimuli, which in turn influences how an educator interprets the behavior. In situations like these, the learner performance yields to these errors, thus not giving the learner fair and trustworthy conditions, potentially circumventing their pathway in achieving their activity-driven goals needed to achieve competency. What I also found were the attributes and performance tasks authors believe to influence simulation setting reliability. This discovery completes the third layer of the cake, showing that reliability in HPE does not account for the social aspects of a healthcare simulation setting. The authors conceptualize that reliability of a setting is influenced by SP performance constructs like inefficiency, inconsistency, or inaccuracy in combination with several simulation design attributes, like rehearsals, portrayal, and the use of measurement tools educators sometimes want SPs to use to rate learner performance. From deconstructing and reconstructing my coded data, I revealed a pattern. As a framework, I believe this process may help operationalize the achievement of simulation setting reliability. It has yet to be tested, so if you're watching this, please try it or share this video with someone you know who would like a challenge. If you need ideas of different phenomenons you'd like to experiment, the next slide is a screenshot of the 6 processes authors perform to reach setting reliability. Because this study is looking at healthcare simulation as a social practice, all the training is tailored to achieve SP performance reliability. So here, if we remember the Venn diagram, we talked about the attributes of simulation design that authors thought that influence setting reliability, or SP performance. Again, case complexity, measurement instruments, inefficient SP training, and timeframes, which cause fatigue. This will talk about the phenomenological activity, which is the research study, and how they tested that out to train the SPs to either achieve reliability and standardized performance, portrayal performance, reproducibility, or replicability. Excuse me. These terms are actually defined at the end of my presentation because there's a list of them at the end of my presentation. These are the types of education methodology. This is not an exhaustive list. And in the context that they were doing their study, whether it was a summative or formative assessment. And they do assess SP via accuracy, post-test, or another term that was found related to reliability, which is calibration. Accuracy, if you remember, is synonymous with validity in HPE. This is the screenshot of the 6 type of processes that I found from the 6 articles that authors use to mitigate reliability in achieving SP performance reliability. So, mitigate errors and to achieve SP performance reliability. This is reliability in HPE and simulation classically defined or conceptualized. You can see here in red, I have bolded the types of terms that are related, and you can see across the board that consistency transfers over to reliability in HPE and healthcare simulation, which makes it kind of confusing. So here I define consistency, and basically it is that SPs have a sound understanding of the purpose of the simulation and participant skills being targeted. This performance has to deal with SP performance over time. I'll go ahead and go to the next slide because I know that you guys can rewind the video. The takeaway from this is that this research serves to promote others with bridging and identifying key components of education theory specific to a simulation framework. It clarifies the concept and the mapping to design and deliver, assess, and evaluate SBE simulation-based education activities in healthcare education. This research also discovered that healthcare simulation setting reliability is underpinned by SP's training that is tailored to mitigate the introduction of errors to a setting consistently. In the realm of simulation, consistency means that a SP should have a sound understanding of the purpose in simulation, participant skills being assessed, and the tools needed to elicit those behaviors. To rate this article, please go to the Curious website, which is published in the Military Medical Simulation channel. I believe that Dr. Molina is actually the editor for this channel. Please go ahead and rate it. You can also reach us on Twitter if you have any debates or discussions about what we talked about. And then I will go ahead and insert my YouTube link here once I upload it. Thank you very much.